Hello, everybody. How are you? Having a nice day? Well, I am Vicente Herrera. This is my colleague Alberto. I work at Control Plane. I am a principal consultant there, where I work for cloud-native security things. I am also collaborating as a contributor to the FINOS Foundation, FinTech Open Source Foundation, part of the Linux Foundation, on AI governance framework that we will mention at the end a little bit. And I also teach AI ethics at Loyola University in Seville, and blockchain, completely unrelated to this, but that's something I also do.
Thanks, Vicente, for the presentation. I'm Alberto. I also work at Control Plane as a cloud-native engineer. My background is on Kubernetes cluster administration, cloud infrastructure management, and software supply chain security. I actually work for a client that is a big financial institution related to open source ingestion. Currently, we are dealing with securing the open source software, vendor software, and very soon we will be dealing with AI models. On my free time, I like to research about AI security. That's the reason why I'm here today speaking. Yeah, super thrilled to be here.
And this presentation, these slides are available on that QR code and that short URL if you want to open it for any reason right now. We are also preparing a blog post that is not currently available at this very moment. It will be maybe later today. But we will provide more information that can be put into the time we have for this talk, this extended information in the blog post. And we also will share a GitHub repository with a lot of information, some notebooks that we will describe also a little bit. So this is like a selection of things for an introduction on something you can research more on your own, but we will guide you a little bit on what could you be looking into, depending on what is your interest. So we are here to talk about AI. We're going to talk about safety, robustness, security, responsible AI. You may hear all these terms used at the same time, and everybody is very worried about this because supposedly AI is going to be everywhere. But there is sometimes no clear path on how to make AI secure. What can you use to improve things regarding these topics in general? This is a taxonomy that we are putting together to try to analyze all the tools that we have found for our research on open source projects, tools, libraries, datasets around that. But instead of explaining this in a theoretical way, let's go one by one into these tools and let's explain a little bit what this means when we describe them. And we very broadly can mention there are some things we can do before deploying AI models. There are some things we can put in place for the models when they are running. And there's information that is going to be useful for us on what's going on, what are the risks, what are the mitigations, and how to manage all this. AI can be many things. We know about latest LLMs, ChatGPT, Claude, Mistral, all these tools. But there is also regular machine learning that we will mention that has something for us interest. But if we talk about what people have in mind today, that is LLMs, the first thing you may know about an LLM is that they publish there is a new version of something, ChatGPT, new version. There's these benchmarks of how good it is, how well it performs, how safe it is. Okay, MMLU, AI Eval, BBQ, different acronyms that in general means the more high the better, but it seems they are very high already. So can you trust this value? Is that relevant to you if they're already so big? Well, you can conduct your own evaluations. You can use LM harness or other things like those we're going to describe here to check how well the models perform. And it's important to know that models are evaluating in isolation, but in your specific system, with your customization, your custom system prompt, your RAG database that you are providing your own knowledge base, the model may behave differently. So doing your own evaluations is something that is interesting to know. Now, regarding safety, evaluations that are interesting for you can be conducted with these example data sets. And again, in our blog post, in our references, there are more information on additional data sets. But let's focus on these three to have a sample. You have real toxicity prompts that studies neural toxic degeneration. How can you make the model start to say nasty things? Let's say, let's go for the more general description of that. And that's relevant to you because maybe a user can make, say, the model something nasty, then it takes a screenshot, there's a reputational damage, maybe that is connected to another thing that degenerates. So it's important to know the system can be protected this way. BOLD is another data set that the studies regard, that is polarity towards a demographic, or how commonly people talk about this bias, that is a word that people mention a lot, that is important for us that the model performs well. And HONEST is another data set that is interesting for harmful sentence completions. How, again, something can be mentioned by the model that entices the user to do something that's harmful for themselves, or if you ask for instructions on how to build something that can cause harm to others, how the model will refuse to do so. Okay? So these are data sets, and you have to provide your means of doing evaluations for this. You can use libraries like Evaluate. There's several ways to do that. Now, in the link you have there for opening in Colab, you will find a Colab notebook that is like similar to Jupyter notebooks, but Google will provide compute for free for you to run those, and you can execute your evaluations and see models being evaluated in a way that you can very easily transfer that example for your own usage. Okay, so that is something useful to learn how evaluations are conducted and how to do your own. If we aim more towards security, another very interesting tool, and by the way, I forgot to mention, we have to thank all the people that have working into these tools, data sets, and the open source community, because thanks to them we have such a big, broad array of tools. So it is thanks to them that we can talk today about all these things. Now, Garak in particular, very well maintained tool that you can use as a CLI installed with pip, but it's a CLI that you can run very easily. And it will execute several probes, several evaluations for different metrics regarding security in specialty. Some things are also talking about copyrighted material, replenishing training data, but mostly focused on security. Now, these evaluations have to be conducted repeatedly, and you measure if in any of the attempts the tool will stop to fail the evaluation, and because the output is non-deterministic and it's slow, it will take hours for you to complete a full evaluation of a model with all the props. So this is a tool that is slow to use, but very thoughtfully checks security in your models. Now, all that is good for pre-deployment. If you go to running, LLM guard is something that can be put in place when things are running to check prompts, to take into consideration these kind of metrics, to stop the conversation and ask and answer the user, I can't answer about this. And there's also several other filters that I could put in place with this kind of tool. And again, an example from us for you for easily test this and see how the evaluations are done. Sorry. Now, GISCAR is similar to Garak, but it will create for you data sets bespoke for some specifics of the description of your model, and it takes more into consideration safety and not only security. So it's interesting because it is more tailored to your own model, but there has fewer, let's say, questions in the data set to evaluate things, but it's more meant to be done something continuously that doesn't take hours to execute. So that's why it's more lean in its usage. And this is an example of the output you can come. That's very nice. And Promptfoo is a very interesting one to compare models, useful to compare models, but you have to provide your own data set of the experiments of how you are going to evaluate the model. So if you don't have such a data set, it's just plotting for you the answers of them, but you have to build the thing yourself. So it's not easy to use in this regard. You have your own, sorry.
Okay, I'll take over from here. And yeah, I'm going to start with Adversarial Robustness Toolbox. It's a tool designed to assess the security of machine learning model. One thing to clarify is what we mean by machine learning model, because we found out there's a lot of confusion with this term. Basically, when we talk about machine learning models in the context of this talk, we are referring to models that are traditional AI models, and we are not including LLMs. So, for example, a traditional classification machine learning model would be considered, would fit into this category, essentially. Adversarial Robustness Toolkit. Okay, so we consider it like a standard in terms of machine learning evaluation. It was originally developed by IBM, and it was donated to the Linux Foundation. And essentially, it's a Python framework that helps assessing the security of machine learning models. It covers red teaming, meaning attacking the model, blue teaming, which covers defenses, and also evaluation and metrics of models. You have, in the next slide, you will find the link to the Collab notebook that we have with an example. It covers a wide range of attacks. We just ran one of them, which is a database reconstruction attack. The goal of the attack is to reconstruct the training data set to which you have partial access. And we run the attack both by applying a defense and also on the raw model. And we can see how the defense provided by ART helped a lot in preventing this attack. In general, we think the tool is very well maintained. It covers a very wide range of attacks, and it basically can be considered like a standard. It can be sometimes challenging because, especially if you don't have a lot of experience in the machine learning landscape. Okay, this is one of the example attacks you can run. Essentially, you introduce some noise in some image or in some video, and you are able to trick the model into misclassifying what it's trying to recognize. In this case, like which sports this guy is playing. Okay, AI fairness is also targeted against machine learning models. Is backed by. Sorry, there's a typo here. It's backed by IBM actually, and it was donated to the Linux Foundation. And this tool is specific for bias and fairness, which we believe is really good because there are many tools that are only focused on this. It has three main components. It has estimators that are used to mitigate somehow bias in models and apply fairness. This can be machine learning models or any library that is used to this. It contains metrics. It contains two kinds of metrics. It has individual metrics that try to assess that similar individuals are treated similarly by your model, and group metrics that just calculate some metrics about subgroups within population. Lastly, it comes with something they call detectors, and detectors are very useful to identify subgroups within your data set that are discriminated or favored. So, for example, if you are considering like basically define, by the input that you give the model, you can define subgroups that can be discriminated against. In our personal experience, it comes with a very broad documentation. It was really easy to use. It's relatively lightweight, and as we said, it's really good that there is a tool with such a level of maturity that addresses bias and discrimination. Okay, this is the example that we run in our collab. Okay, Nemo guardrails, again, a tool that is very, very well maintained, is backed by NVIDIA in this case. And this tool helps you define guardrails that try to control the conversation between the user and LLM. This tool ideally will sit between the user and the target LLM that you're trying to protect. It helps you running model in several ways. You can use NVIDIA Cloud for it. You can run it locally using a library called VLLM. And you can also protect models that are hosted via API, like, for example, ChatGPT. It comes with a language. They created a language for defining Rails that is called Golang. And the goal is basically to guide the behavior of the LLM in the conversation with the user. It implements, as we said, Rails that can block basically prompts from the user and responses from the LLM model. And they have like 3 kinds of Rails. The first one we found it really interesting. The first one is self-checking guardrails that basically uses the target LLM that you're trying to protect to try to assess whether the prompt or responses are safe. It also comes with community models and library that helps you determine whether a prompt or a response from the LLM is safe. And also it helps you use like third-party APIs, like for example, private AI to assess that the prompts and responses are safe. In terms of features, it covers content safety, security, hallucination detections, fact-checking, and basically anything that these models that it uses or third-party APIs provides. In our personal experience, it has a very nice level of maturity. It's backed by a great company like NVIDIA, and it has many integrations, which is great. Okay. Again, you have the link to the collab in the presentations. Yeah, and now LangKit. LangKit is used for runtime monitoring of your language models. Is backed by another company called Y Labs. And this tool focuses more on observability. So like Nemo Guardrail sits between the user and the LLM. And the idea is to extract relevant information from the conversation that you can then visualize in 2 ways. You can visualize it by sending the logs to the Y Labs platform, which you have to pay, of course. Or you can store them locally and visualize it with a library that Y Labs provide as well. In terms of features, it covers text quality, relevant content. That means that the conversation sticks to the relevant topics. And security and privacy, like basically jailbreaks, prompt injection detection, hallucination, and things like that. Okay, this is an example of the kind of metrics and insights that you can get from it. Talking about Inspect AI, it's a very reasonable maintained tool. It's backed by OpenOK, which is a British non-profit organization. And is essentially a benchmark for large language models. I think its main asset is that it's really lightweight and easy to use, and also that it evaluates a lot of stuff apart from security, which is great because we believe that LLM model assessments should be done you should evaluate everything, basically, not only security, and evaluation should be complete to assess like the model performance in general, and not only assessing security in isolation. Okay. Again, you have the link to Collab. And the last tool that I'm going to be talking about is BrokenHill. I don't want to spend a lot of time on it because it's not very well maintained, and we don't think that it's really ready to be productionized. It's backed by Vision Fox, which is an enterprise. But to be honest, we had a lot of fun with BrokenHill. It only performs one attack called the greedy coordinate attack. That is essentially a jailbreak attack, a jailbreak adversarial attack. By jailbreak, we mean that you are trying to make the LLM respond something that is not supposed to respond. And by adversarial, we mean that you are using another model to attack the target model. In our example, we asked about how to, like the LLM, we asked the LLM to come up with a plan to annihilate the human race. This is the prompt that it came up with. As you can see, it introduces a lot of strange characters and a lot of keywords, essentially. And yeah, for a reasonable price, I would disclose that information if you DM me on LinkedIn. And yeah, handing over to Vicente.
Yeah.
Again.
Well, I don't know if it was wise to include the duck with the plans to annihilate the human race, because they hate us a little bit. Okay, so now we enter in the territory where we have a lot of tools that we could be talking about, but in general, they tend to be very similar to ones we have mentioned before. So we have in the slides a lot of information on other tools that we will just mention a little bit now. Garak AI is one of it. It has many pros that you can active. It's a runtime tool that is going to detect something going on with the LLM that you want to block, potentially. And some interesting thing is that you can include Llama Guard or Shield Llama 2, that are models to detect harmful content or detect security violations. But as a remote inference, you have to pay something to do it. And Purple Llama models, again, open weights but not open source, that you can use to detect things. Shield Llama, similar situation, models to detect things, but you have to put together how to run the model. Pin a tool to evaluate, but you have to bring your own evaluation. There is similar tools that maybe are not well maintained or a single individual, or lacks something in place or have a couple of commits. So you can study this, you can research. Again, we have provided you many examples to do it. We want to end mentioning again Finos Foundation, FinTech Open Source Foundation. We are collaborating here to describe a procedure to successfully say that you have put AI safe on a highly regulated environment. In this case, financial institutions, banks, are collaborating together in this foundation to do so in an open way. So it's very interesting. It's an early stage, so there is not a lot of information. But right now, the focus wants to be not only on the risks, but what are the right mitigations that you have to use. So this is something that you can look for. Also, in control plane, we are putting together a reference architecture that is an example that you can run and deploy, which would be a proxy, AI proxy security filter to intercept communication with an LLM, and in this case, use other tools to bring security, like LLM Guard, for example, in this example. The idea is that you can put this container in place and run something that then you test what's the behavior, and you don't have to fetch and put a lot of things together. It's already there for you to evaluate tools. And whatever you do, consider that you have to check things on your specific system with your specific custom prompt, with your RAG application on your environment, because things will change, and as your environment evolves, it will change again and again. Okay? More reference here, and that's it. Thank you very much, and I hope this will be helpful for all of you.
If you have any questions, I think we have time for one question. You have the mic over there.
If you had to write one tool yourself today to solve a problem, what would you write?
Well, there is a lot of work on all of these tools, even the ones that are more basic or not well maintained. I think it won't be wise for me to do so. I would contribute to one of them in a way that I can take advantage of what is already there and add my own checks or put my own data set or add the piece of thing I need from that. And in that regard, I would start with Garak for evaluation of security and LLM Guard for runtime. Those are the two legs that are for me like a foundational thing, but other tools have a lot of sense in different situations. Okay?
Any specific feature you would want in any specific tool?
I would love to see Garak have more things that are not only security, but are more safety and responsible AI focused. But that's something you can do. You can just take those data sets that I described and implement the probe inside Garak to run them. That's something that's possible.
All right. Any more questions we can take in the hallway track? All right. Thank you so much.
Thank you. Thank you very much.